This is the first of two videos where I'm going to talk about functions. So we have functions here, and then we have composition of functions in the next video. And that's the algebra of functions. You'll also find functions covered in coordinate geometry. So functions are plug-in problems as far as the ACT is concerned. The plug-in problems on the ACT are here. They're in the elementary algebra plug-in problems. You can check out that material in that video. They're also in trig identities. Shows up a lot. It's an important skill to have. Let's talk about a function in general before we get started on anything else. F of x is equal to x plus 1. Very simple function. This is an example in the book that's discussed at length, but let's talk about it kind of quickly here. There's three kind of components, basically. This is the output, and it's a stand-in for y. F of x means y. And it doesn't have to be f. It could be g of x or any other letter. G and f are most common. X is the input, and it's also the x value. And this here, this expression, the equation part of the equation, is the relationship. So the confusing thing, I think, for people in general is this f of x, because there's an x over here. Do you divide to get rid of this x? No, this is a placeholder. What this notation is telling you is that the function of x is a placeholder for any number you want to put in here, is equal to this. So what it's saying is the relationship between y, or f of x, which is y, and all the inputs of x is this. This relationship always it works. And of course, functions can be bounded, right? They can be piecewise, but we're not going to talk about that right now. This function is always true. This is a linear function, right? X plus 1. Slope of 1, y-intercept of 1. So what I'd end up doing is I plug in whatever is in the parentheses for x. So it can be numeric. I could have f of negative 2. That means I want to know what the output, what the y value is when x is negative 2. So what do? I plug in negative 2 wherever I see x. Sorry for the squeaks on the marker. Combine these two. The output, the y value when x is negative 2 is negative 1. But it doesn't have to be a numeric thing. Sometimes I'll substitute in other variables, and that's what people typically find trickier. So let's say it's f to the a squared, right? X plus 1. Well, whatever's in these parentheses goes in for x. F to the a squared is equal to a squared plus 1. And that's all I can do on that one. So the output when x is a squared is y is a squared plus 1. That's it. Okay, let's take a look at the problem on the bottom of your screen. If f of x, I'm just going to leave this up here as a reference. F of x is equal to x squared minus 4, then what is f of y plus 2? Y squared plus 2, excuse me. So what do? Plug in y plus 2, even though it's two terms. Plug in anything in that parenthesis wherever x is, and the same thing that happens to x, or things that happen to x, happens to y squared plus 2. So y squared plus 2 squared, because that's square, minus 4. Now, if you don't remember from the expounding video in that material, in the factoring section, whenever I square a whenever I square a binomial, two terms, I have to multiply by itself, which means I FOIL. I can't just sort of distribute that. So this becomes y squared plus 2 times y squared plus 2 minus 4. First, y squared times y squared is y to the 4th. Outer plus 2y squared. Inner plus 2y squared. Last plus 4 minus 4. You'll see these 4s will cancel each other out. And that leaves you with, I'm going to move it up here, y to the 4th, combine these terms, plus 4y squared. Plug in problems every time. Now you'll see some more sophisticated examples of this both in the book and in the problem set. I really encourage you to work these. These are a staple of the ACT. They're very, very doable. You just got to get over that hurdle. The hurdle of knowing that you just plug in whatever's in there into the equation for x or whatever variable they decide to use. Just practice it. Be comfortable with it. It's a comfort thing more than anything else. Check out the video on composition of functions because that is the same principle, but it gets a little more complicated.